Pertaining calculations involving capacitors, for this level, we are going to show some basic formulas that you need to analyze or to do calculations that involve capacitors. So the first thing we are going to look at is the formula for calculating what we call capacitance. Capacitance. So before I just write capacitance, label C, label capital letter C. So capacitance is defined as the amount of charge a capacitor receives per unit voltage. In my introduction of what capacitors is, I said that they store what charges when voltage is applied on them. So the quantity or the term called capacitor is a term that we use to measure the amount of charge a capacitor is capable of holding per unit voltage. That's per unit voltage, each voltage you apply to a capacitor, how much charge is it capable of holding with such a voltage. So that's what we define capacitance as. So capacitance is what? Amount of charge, Q, divided by what? Voltage, means the amount of charge the capacitor is capable of holding or acquiring per unit voltage without getting damaged. You understand? Yes, because if you overcharge a capacitor to some extent, it will blow or get destroyed. So the first formula is C, which represents capacitance, equals to what? Q divided by V, where Q here is the charge. Q equals to what? Charge. And the unit for charge there is coulomb. Coulomb. C, letter C. And then V there is the voltage. And the unit for voltage is what? Volt. So this is the first formula that you need to know. And then capacitance itself is measured, the unit of measuring capacitance is called farad. It's called what? Farad. So, however, there are some prefix that we usually attach to the unit of capacitance, because in practical application, if you have really been into electronics, you find out that when you want to buy or acquire capacitors, you see that their ratings is usually in microfarad, nanofarad, and millifarad. So the prefix milli, if you say millifarad, it means what? 10 raised to the power of minus 3 farad. And then when you say microfarad means what? 10 raised to the power of minus 6 farad. And then if you say nanofarad, small letter n, nanofarad means what? 10 raised to the power of minus 9 farad. But the unit of capacitance is what? Farad. All these other ones are prefix attached to them. So this is the first formula you have to take note of. So we look at the second formula for capacitance. Now, the capacitance of a capacitor depends on several factors. So this other formula is a formula with respect to the construction of a capacitor. The formula with respect to what? The construction of a capacitor. The first one I gave is from the definition of capacitance. From the definition of capacitance. So this second one will be from the construction. So let's look at what affects the capacitance of a capacitor in terms of the materials, or in terms of what we use to construct, or how we construct a capacitor. So now you look at a basic construction of a capacitor. Here you have two parallel plates, and then you have this parallel plate. They are separated by a distance labeled D, and then these parallel plates here have between them what we call dielectric. Dielectric is the material between the parallel plates of a capacitor in which electric field is being stored. The electric field is being, generated there. So to analyze now, the capacitance of a capacitor is directly proportional to the area of the plate. So that means the bigger the plate, the more the capacitance of the capacitor. These are key points you need to take note, because they may be asked what does the capacitance of the capacitor depend on. So it depends on the area of the plate. The bigger the plate, the bigger the capacitor. And then capacitance is inversely proportional to the distance of separation, D. Is inversely proportional to the. That means the further the distance, the lesser the capacitance. That means the further the distance, the lesser the capacitance. So those are the two basic variables that capacitor depends on in terms of construction. So with this variation, if you now change it to equality sign, you attach your constant of proportionality over D, where this letter here is called epsilon. This epsilon here is called the permittivity of the dielectric, or you say the permittivity of the material between the plates of a capacitor. So sometimes it's a vacuum. That vacuum means air, space, nothing within them, just air. So each material has its own constant of permittivity. It all have its own electric permittivity capabilities. That is permittivity. So take for instance that permittivity of air, or you say vacuum, epsilon naught, usually labeled epsilon naught, is given as 9, approximately as is 8.9 something like that, but you approximate it for this level is usually approximated for the learners. So approximately 9 times 10 raised to the power of minus 12 farad per meter. So every material has its permittivity, electric field permittivity. So this one, 9 times 10 raised to the power minus 12, is that of air, or you call it vacuum, in which that's the one that you will be calculating with under this level, O-level physics. But for higher level, you have to have that your epsilon relative permittivity equals to that of the material times that of the air, but that is not for this level. So now we have established the second formula, which is this, where E here represents permittivity of the space. So the unit of capacitance is still in farad, and then the unit of area here, area of the parallel plate, is meter square, and the unit of the distance of separation is meters. So when you are calculating and any of these unit any of this quantity is given in unit prefix other than this, then you have to convert it to their standard unit. Take for instance, they give you the area of the plate in terms of cm, say 100 centimeter. For you to substitute this into the calculation, you have to convert it 100 cm squared. You have to convert it to meter square. And how do you do that? You do 100 times 10 cm, centimeters, 10 raised to the power minus 2, which is the same thing as 100 divided by 100. Divided by 100 meters, which will give you 1 meter. It will give you 1 meter squared. So this is the second formula you have to take note of with respect to construction of a capacitor. All right. Okay. So now let's look at series and parallel connection of capacitors. The first diagram you have here is called the parallel connection. Parallel connection is when each capacitor or when each device is being shares a common terminal with another device. Like it says C1, C2, C3. They all share a common terminal A and B. But this other one that is in series, they don't share the same terminal. Rather, they are connected end to end. One is connected to the end of the other one. Like you see here, C1 is connected to A, but its end is not connected to B. Rather, its end is connected to C2. So that's a series connection. And C2 is connected to C1 and its end is connected to C3. That's a series connection. They are not sharing the same terminal. So they are connected back to back, end to end. So this one is called series connection. So the few points you need to note about the connection is this. For the parallel connection, the equivalent capacitance C is given by the algebraic sum, or is given by the sum of the individual capacitance. That is C1 plus C2 plus C3. So that means if the capacitance of C1 is 1 microfarad or 1 farad, and C2 is 3 farad and C3 is 2 farad, the equivalence will be what? 1 plus 3 plus 2. That will be about 6 farad. So it's as simple as that. That will be the equivalent capacitance of the three capacitors combined. So that's the first point there. And then the second point you have to know, okay, for parallel connection, is that the potential difference across each capacitor is the same. So V equivalent or total voltage is the same thing as the voltage across the first branch, same as across the second branch, and same as across the third branch. So in electrical engineering or circuit theory, whenever devices share a common terminal, their voltages usually remain the same. So the third point you have to know about a parallel connection is that the equivalent charge of the capacitors combined is equals to the sum of the individual charges. Q1 plus Q2 plus Q3 plus Q3. So you see, so if they ask you what is the equivalent charge between point A to B, that means you have to add the individual charges on the capacitors. Q1 plus Q2 plus Q3 will give you the equivalent charge. They don't share the same charge. You understand? Yes, it's just like current. It's just like current. Current, they don't share the same current. So depending on the value of the capacitance, will determine what charge is going to accumulate at that particular capacitor. So those are the points for parallel connections. So if we come to the series connection, the equivalent capacitance C is given by what? Or should I say is the equivalent capacitance is given by 1 over that equivalent capacitance equals to 1 over C1 plus 1 over C2 plus 1 over C3. So when this is the formula for evaluating the equivalent capacitance of capacitors connected in series, so what happens is when you are solving, after inputting the values, you have to make C here, this C here, the subject of the formula. Okay, take for instance, if you have the first capacitor to be 2, then this one 3, and then this one 1, 2 farad, 3 farad, and 1 farad, and then you are asked to evaluate the equivalent capacitance. What you have is 1 over C equals to what? The first one will be 1 over 2, plus the second one will be 1 over 3. Third one will be 1 over 1. And then when you evaluate this, 1 over C will be equals to the LCM of the denominators there is 6. So here you will have 3 plus 2 plus 6. This is addition of fractions. Okay, so you end up having, this is 5, this will be 11 over 6. So your answer is, what you now have left is 1 over C equals to what? 11 over 6. Then you take reciprocal of both sides, so that C over 1, or it says C equals to what? 6 over 11 farad. So that is how to evaluate this one. Now the next one, you have to the next point here, number 2, will be that the equivalent charge Q will be the same for any of the capacitor. So equivalent charge Q is the same charge you will measure across C1, which will be Q1, is the same that you measure across C2, which is Q2, and it's the same you measure across C3, which is Q3. So that means they share the same charge. It's similar to the theory of current in series connection. The current is the same. Then for capacitors in series connection, the charge is the same. So the third one that you need to take note of is the voltage. The voltages are different. So the equivalent voltage will be the summation of the individual voltages. V1 plus V2, where V1 is the voltage across C1, V2 voltage across C2, plus V3 voltage across C3. So they don't share the same voltage like that of parallel connection. So their voltages are the same. So equivalent voltage will be what? The summation of individual voltages. So those are the basic points and formulas that you need to know to do calculations in pertaining capacitors for this level. In a capacitor labeled E, or you can call it, if you decide to call it W, energy level, the capacitor is given a half of charge times the voltage. Then you recall that that a capacitance equals to what? Charge over voltage. And if you make V the subject of the formula, you have that V will be equals to what? Q. That's from here. If you make V the subject of the formula, V equals to what? Q over C. So if you substitute that in place of V here, you also have it to be a half of Q times another what? Q over C, which still gives us what? A half of Q squared. Q squared over C. So you can play around these formulas. Even as this, if you make from here, from this same equation, if you make Q the subject, Q will be what? C times V. And then if you substitute it in this one here, you substitute that in that one there, you have it to be a half of CV squared. So any of them that you can do. So the first one is a half of QV. Then from the initial formula of calculating capacitance, you can do substitution. So it depends on what the parameters of your questions are. Then you decide on what formula to use. So it's as simple as that. Thank you.